Hello everyone, welcome back to CSC 151 Computer Applications. In this video we're going to go through over while loops. So what exactly is a loop? A loop is something that repeats itself over and over again. It's a section of code that will continue going until we tell it to stop. For example, if I say x equals 0 and I say while x is less than 5, and I'll use the same colon that I do at the end of any of my if statements. So I get that indentation. I simply, say, print x, and then I say x equals x plus 1. Basically what I'm doing is I'm saying, this loop will continue until x equals 5. We will always have x be printed, and then we'll add 1 to x. So it goes 0, 1, 2, 3, 4. And you'll notice that 5 does not get printed. So let's read this out. X is 0. 0 is less than 5. Therefore, this is a true while loop. So while it's a true statement, that means, okay, print x. What is x? 0. That 0 is now 0 plus 1. So it's 1. That right there is now the end of the loop because there's nothing else after it. So we jump back up to the top. 1 is less than 5. Print 1. 1 is now 1 plus 2. Back to the top of the loop. 2 is less than 5. Print 2. 2 is now 2 plus 1, which is 3. 3 is less than 5. Print 3. 3 is now equal to 3 plus 1, so it's 4. 4 is less than 5. Print 4. 4 is now 4 plus 1, which is 5. We get back to the top. 5 is less than 5. Well, that's false. So this stuff right here gets skipped. The loop is over. That's how a loop would work. And what matters now is the order of operations. So if I cut this out and I put it in reverse, now I'll have a 0. 0 is less than 5. 0 is now equal to 1. Print 1. So I'm not going to get that 0 there anymore because of the way these orders of operations happen. Remember, a computer will literally go line 1, line 2, line 3, line 4. It will go in order. So if I tell it to add 1 before I print the number, I'm going to get 1, 2, 3, 4, 5 like that instead. Now, that's just how that can wind up going. Now, the other thing I can do here is instead of saying x equals x plus 1, I can just do plus equals 1. And I'll get the same thing. The plus equals is a shortcut, meaning itself plus whatever I say here. If I did minus equals, I would obviously have it going in reverse. But if you notice, now that I have this in reverse, let's take a look at how this is going. Will this ever end? Probably not. Why? Because x started at 0. 0 is less than 5. 0 minus 1. Negative 1. Negative 1. Negative 1 minus 1 is negative 2. This will always be less than 5. And that's what's known as an endless loop. It will continue on forever and ever and ever and ever and ever until you either run out of computer space, break the program, or tell it to stop, force quit manually. You don't want to do an endless loop, okay? Because obviously that's not how that works. That would be bad. So always be aware of endless loops when doing something like this. So, yeah. Plus equals will work out better in this scenario. Now, if I wanted to do this in reverse, say if I had it at 10, and I wanted to go while it's greater than 5, then I could do minus. That would be perfectly fine. 9, 8, 7, 6, 5. Works out just like that. Or if I, once again, switch my order of operations, 10, 9, 8, 7, 6. Easy peasy lemon squeezy. And just like always, and let me just start this off at 0 here, just for the sake of, let's get this back to our kind of original concept. There we go. You can, in fact, have a loop inside of a loop. So let me say while y is less than 5. I'll do the same thing with y. So let me just make myself a y here. Y equals 0. You can nest a loop inside of a loop if you want to. You can nest an if statement inside of a loop if I wanted to. So, boom, print y, and y plus 1. So let's take a look at what's happening here. So, for every loop of x, it'll print x. And then every single time it does y, it'll do this. So we'll get this sort of bizarre scenario where we get 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, because it's doing this, print that, add that, and then doing this loop right here before going back to this one. Matter of fact, it would even be more obvious what's happening if I did it this way. So I always reset y, so I'll essentially have a loop, I'll have this loop run to completion before I even get to the next step in this loop. So in theory, I'll see this guy run to completion, 5 times, basically. So let me just make that 3, just so it's super obvious what's happening here. 0, 0, 1, 2, 1, 0, 1, 2, 2, 0, 1, 2, 3, 0, 1, 2, 4, 0, 1, 2, and there'd be the 5. This loop is continuing itself over and over again, while this one is, doing whatever it is it wants to. Matter of fact, let me, just to make sure that this is super obvious, I'll make this a 10, and I'll make this a 15. Just so we have double-digit numbers to showcase. There's our 10, there's our 11, there's our 12, there's our 13, there's our 14. There's the y loop going over, there's the second loop of the y, there's the third loop of the y, fourth loop of the y, fifth loop of the y. And there's 1, 2, 3, 4, there's the 5 bits of our x loop. So you can have a loop essentially count itself out every single step inside another loop if you really wanted to do that. And let me just scroll through this. Is there any other example I wanted to show here? Oh yeah, I'll show this example. So, when could you possibly do a loop, though, that, considering doesn't want to, we could have like a Boolean in a loop. We haven't done Booleans in a while, so let me just go and say x equals true. Okay, so we know we're dealing with a Boolean. And I can say this, while... Actually, no. Let me just start with 0. So while x modular division... Actually, no. Less than 9. Because there's 9 squares in a tic-tac-toe board. Let me do that. There's 9 squares in a tic-tac-toe board, so there'll be a maximum of 9 turns. I could put an if statement inside of this as well if I wanted to. So if x is modular division 2, so basically I'm using the remainder, figure out what the remainder is. So I'll either have a remainder when I'm dividing by 2 of 0 or 1. So I could say equals 0. And I'll say print x's term. Else print O's term. Because it's either x's or O's. And then, of course, at the end of that loop, whether or not it gets here or there, I have to make sure that I have x plus equal 1 to always increase it. So in theory, this should alternate between 2 different options. X's turn and O's turn, 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 and X's turn. So essentially, I have myself now a loop of deciding the turns of tic-tac-toe. And in theory, I would put other stuff in here to actually have players select the square and what they're going to do, so on and so forth. But I have just essentially flip-flopped between 2 different things. I could also do this with a Boolean by simply having 2 variables, making x true and y untrue, or and O false. But, I'm not going to do that. And, this one I'll just call the toddler simulator. So I'll say x equals input. Why not? And I'll say, I don't know, why is the earth round? And, there we go. There we go. And I'll say while my while x does not equal because I said so. I'll just simply do this. So now, in theory, this will keep going over and over again until I say, because I said so. Why is the Earth round? Because of gravity. Why is the Earth round? Because science. Why is the Earth round? Because I said so. And then now the code ends. It doesn't ask me another question again. This is jokingly called the toddler simulator. Keeps asking why, until we say because I said so. And that's generally how that works. Now, here's the thing. I could also just simply say something like this, where I say, while true, and leave it at that. Now, what does while true even mean? While true means while this loop exists. So, while this loop exists, well, this loop will always exist. So we get ourselves an endless loop, and I'm just going to repeat the word sugar 700 times over, simply by doing that. Once again, if you wind up in an endless loop, please remember to hit the stop button so you don't break the program. But yeah, that's a lot of sugar. So, that's generally loops. Loops are just simply code that when they get to the end, they go back to the top. As long as the condition at the top is still true, it will still go and continue on with the loop. So, go back up, goes back down, goes back up, goes back down, goes back up, goes back down. And you can keep doing loops over and over and over and over again until the end of time. But once this condition is false, it won't happen. So, while something is true, the while statement, whatever is in the parentheses, will need to be true. If it's true, we will continue on with the loop. If it's not, the loop will be skipped. And this is the basic understanding of loops. In the next video, we're going to actually modify these loops and set some endpoints and start points and other sort of weird stuff like that. See you in the next video.